So actually, the right triangle ADN congruent to the right triangle CGB because the hypotenuse DA equals to 41 units in its length, and the hypotenuse CB of this right triangle CJB also equals to 41 units in its length. And we have also side DN of the right triangle ADN is equal to side CJ of the right triangle CJB because of the fact that the opposite sides of this left triangle DCJN are equal to each other. Therefore, in right triangle DCJN, side DC equals to side CJ. So the right triangle DAN congruent to the right triangle CJB according to side rule. Why? Because we have the hypotenuse DA equals to the hypotenuse CB. They are both equal to 41 units in its length, therefore they are equal to each other. And those two sides are also equal to each other because those two sides are two sides in right triangle DCJN, and therefore they are equal to each other according to the rule that the opposite sides of a right triangle are equal to each other. The first side of right triangle ADN must be equal to the first side of JB of the right triangle JCB. Again, the first side AN of the right triangle ADN must be equal to the first side JB of the right triangle JCB. Why? Because the first side equals to the first side JB equals to CB square minus CJ square, and the CB equals to DA and CJ equals to DN. Therefore, the first side of the right triangle CJB, that is JB, must be equal to the third side CNA and DNA. Therefore, those two first sides must be also equal to each other according to the Pythagoras theorem. The third side AN equals to DA squared minus DN squared. Again, AN equals to DA squared minus DN squared AN equals to DA squared minus DA squared. We have to take the root of DA squared minus DA squared in this right triangle DN. This is the value of AN, while in this right triangle DJB, JB equals to the square root or the root of CB squared minus CJ squared. So the first side AN in the right triangle DAN equals to the root of DA squared minus DA squared minus DN squared, and the first side of the other right triangle CJB equals to CB squared minus CJ squared, the root of CB squared minus CJ squared. But we know that DA equals to CB, again, DA equals to CB, and DN equals to CJ, again. DA equals to CB because the hypotenuse DA is 41 units and the hypotenuse CB is also 41 units, so dA equals to CB, and dN also equals to CJ according to the rule that the opposite sides of an DCGN are equal to each other. So dN equals to CJ. Okay, again, dA equals to CB and dN equals to CJ, and therefore in total we get that AN equals to JB. So this is the first side AN, this is equals to JB. So those two right triangles can go into each other according to angle similarity rule. So it is known triangle DAN, this is triangle DAN, that can go into the right triangle CJB according to angle similarity, according to side rule. But again, the hypotenuse dA of the right triangle DNA equals to 41, and the hypotenuse CB of this right triangle CBJ also equals to 41. So those two sides are equal to each other, and dN equals to CJ because of the fact that the opposite sides of this rectangle are equal to each other. And finally, the third side of those two triangles must be also equal to each other according to the Pythagoras theorem. So those two right triangles are similar to each other according to angle similarity rule. And from the fact that they can go into each other, but again, those two right triangles can go into each other according to side rule. And from the fact that they can go into each other, we will derive that side AN of the right triangle DNA is equal to side JB of the right triangle CJB, according to the rule that corresponding sides that can go into triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say AN and JB, must be equal to each other in their lengths. So from the fact that those two right triangles are similar, can go into each other, we will derive the side AN of the right triangle ADN is equal to side JB of the right triangle CJB. So I don't know, we derive that AN equals to JB. According to the rule that corresponding sides can go into triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say AN and JB, must be also equal to each other in their lengths. So if we define the length of AN as x, then the length of JB must be also equal to x because they are equal to each other. We know that AB in total equals to 50 units in its length, so AB equals to AN plus NJ plus JB. So AB in total equals to 50, and AB equals to AN, that is x according to our definition, plus NJ, we already found out that NJ equals to 32, plus x. Side AB, that is equals to 50 units in its length according to what is given in the question, consists of 3 line segments. The first line segment, AN equals to x units in its length. The second line segment, NJ equals to 32 units in its length. And the third line segment, JB, also equals to x units in its length. So we get from this equation that 50 equals to 2x plus 32. Here we subtract 32 from this equation, and we get that 2x equals to 50 minus 32 is 18. So 2x equals to 18. Here we divide this equation by 2, and we get that x equals to 18 over 2 is 9. So x equals to 9 units in its length. So side AN equals to x equals to 9 units in its length. And side JB, this is also equals to x, is equal to 9 units in its length. In the next step, we'll implement the Pythagoras theorem on this right angle CJB in order to find out the length of side CJ. This is actually CJ is the height of this trapezoid ABCD. Again, CJ is the height of this trapezoid ABCD because it's creates 90 degrees with the two bases. Creates 90 degrees with the base AB and creates 90 degrees with the base CD. So CJ is the height. So I'll copy the right angle CJB in a new page and we'll implement only the Pythagoras theorem. Here by PT is the preparation for Pythagoras theorem. So actually, this is the right angle CJB, this is the going from the original drawing. This right angle, according to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right angle CJB is CB, therefore the square of the hypotenuse is CB square, and CB square must be equal to CJ square plus JB square. And again, CB square equals to CJ square plus JB square. So I'll write it down. CB square, that is the square of the hypotenuse, equals to CJ square plus JB square. CB is 41, therefore CB square is 41 square, it is 1681. And it is equal to CJ square. CJ is the missing sign of electricity, so it is CJ square plus JB square. JB is 9, therefore JB square is 9 square, that is 81. So in total, if you found out that 1681 equals to J square plus 81. Here we subtract 81 from this equation, and you get that 1681 minus 81 is 1600. 1600 equals to CJ square. Here we take a look out of this equation and finally get that the missing sign CJ equals to the square root of 1600, that is 40. CJ equals to 40 units in its length. This is the missing sign CJ, this equals to 40 units in its length. CJ is the height of trapezoid ABCD. And we know that the area of any trapezoid equals to the sum of its two parallel bases times the height over 2. Repeat again, the area of this trapezoid ABCD equals to the sum of its two parallel bases. times the height over 2. Its two parallel bases are DC and AB. So it is DC plus AB times the height is CJ over 2. Repeat again, thereafter trapezoid ABCD equals to the sum of its two parallel bases, that is DC plus AB, times the height CJ over 2. DC is 32, plus AB is 50, times CJ, the height CJ is 40, divided by 2. So in total, thereafter trapezoid ABCD equals to the sum of its two parallel bases, that is 32 plus 50, that is 82, times the height 40 over 2. 40 over 2 is 20. So in total, the area of trapezoid ABCD, that is the area that we are looking for in this question, is equals to 82 plus 20. 82 times 20. 82 times 20 is 1640 square units. So if you found out that the area of trapezoid ABCD is equal to 1640 square units. Repeat again, the area of this trapezoid ABCD is equal to 1640 square units in its size. So the next step of the lecture. In this lecture, our task was to find out the area of this big trapezoid ABCD. So, first of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. Repeat again. A trapezoid is a quadrilateral with one pair of parallel sides. In the drawing, we have trapezoid ABCD. Side DC is parallel to side AB, and therefore this quadrilateral is defined as a trapezoid. The two parallel sides DC and AB are defined as the bases of the trapezoid, and the area of this trapezoid ABCD equals to the sum of its two parallel bases, that is DC plus AB, times the height h over 2. If we define the length of DC as A and the length of the base AB as B, then the sum of its two parallel bases is A plus B times the height h over 2. Therefore, in total, the area of this trapezoid ABCD equals to A plus B times the height h over 2. First of all, we implemented rule 2 in our drawing. A bit quickly on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. Repeat again. The lengths of two tangents from a common standpoint to a circle are equal. So, in the drawing, we have in the drawing, we have a circle. This is the common standpoint point P. From this common standpoint point P, we have two tangents to this small circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other and their lengths. That is to say, PA equals to PB. We can implement rule 2 in our drawing. Because in our drawing, if we focus on this common standpoint point C, from this common standpoint point C, we have two tangents to this circle, tangent CZ and tangent CE. And according to rule 2, they are equal to each other. That is to say, CE equals to CZ. So if we define the length of tangent CE as A, then the length of tangent CZ must be also equal to A, because they are equal to each other according to rule 2. Likewise, if you focus on this common point D, from this common point D, we have two tangents to this circle, tangent DE and tangent DL, and according to all two, they are equal to each other. That is to say, DE equals to DL. So if we define the length of tangent DE as B, then the length of tangent DL must be also equal to B, according to all two, because they are equal to each other. Likewise, if we focus on this common point A, from this common point A, we have two tangents to this circle, tangent AL and tangent AT. And according to all two, they are equal to each other. That is to say, AL equals to AT. So if we define the length of tangent AL as C, then the length of tangent AT must be also equal to C, because they are equal to each other according to all two. And finally, if we focus on this common point B, from this common point B, we have two tangents to this circle, tangent BZ and tangent BT. And according to all two, they are equal to each other. That is to say, BZ equals to BT. So if we define the length of tangent BZ as D, then the length of tangent BT must be also equal to D, because they are equal to each other according to all two. So then we calculated what is the length of side DC plus side AB. In total, DC plus AB equals to A plus B plus C plus D. It again, DC plus AB in total equals to A plus B plus C plus D. Likewise, what is the length of DA plus CB? DA plus CB in total equals to A plus B plus C plus D. And again, DA plus CB also equals to A plus C plus C plus D. And because of the fact that those two expressions, they are both equal to A plus B plus C plus D, it means that they are equal to each other. That is to say, DA plus AB equals to DC plus AB equals to DA plus CB. Those two expressions are equal to each other. DA plus AB equals to DC plus AB equals to DA plus CB. DC is the missing sign, so leave it as it is. Plus AB. AB is 50. So this side of the equation we have DC plus 50 equals to DA. DA is 41 plus CB is also 41. So DA plus CB in total equals to 41 plus 41. 41 plus 41 is 82. So DC plus 50 equals to 82. Here we subtracted 50 from this equation. And found out actually that 82 minus 50 is 32. So DC, the missing sign DC, this is the missing sign DC, that equals to 32 units in its length. In the next step, we did a construction, that is to say, from point C, we do perpendicular on AB. Again, from point C, we do perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AB. This point is point J. Likewise, we did another construction, that is to say, from point D, we do perpendicular on AB. Again, from point D, we do perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and AB. This point is point N. Here we implemented rule 17. It is given us the question that side, because of the fact that ABCD is a trapezoid, a trapezoid is a quadrilateral with one pair of parallel sides. The two parallel sides in this trapezoid ABCD are BC and AB. That is to say, DC is parallel to AB because it is a ABCD is a trapezoid. So DC is parallel to AB. Those two angles are defined as one-sided interangles, and they are located between the two parallels DC and AB. And because of the fact that those two one-sided interangles are located between two parallels DC and AB, they must be equal to 180 degrees in total. You can repeat again on rule 17. According to rule 17, the sum of one-sided interangles that are located between two parallel lines is equal to 180 degrees. In the drawing, we have line A that is parallel to line B. The red line C cuts those two parallel lines A and B. We have those two angles are defined as one-sided interangles. With again, angles alpha and beta are defined as one-sided interangles. And because of the fact that those two one-sided interangles are located between the parallels A and B, the sum of those two one-sided interangles must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. So we can implement rule 17 in our drawing. In our drawing, you know that side DC is parallel to side AB because ABCD is a trapezoid. Those two angles are defined as one-sided interangles, and according to rule 17, the sum of those two one-sided interangles that are located between the parallels DC and AB, the sum of those two one-sided interangles must be equal to 180 degrees. That is to say, this angle equals to 90 degrees according to our construction. 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to rule 17. So 90 degrees plus this angle that is CDN, in total they must be equal to 180 degrees. If we subtract the 90 degrees from the equation, we find out that this is the missing angle CDN, that is equals to 180 degrees minus 90 degrees, it is 90 degrees. So this angle equals to 90 degrees in its size according to rule 17. Likewise, those two angles are also defined as one-sided interangles, and they are located between the same parallel lines DC and AB, and therefore the sum of those two one-sided interangles must be equal to 180 degrees according to rule 17. So this angle equals to 90 degrees according to our construction, plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to rule 17. So 90 degrees plus angle DCJ, this angle, this is the missing angle CJA, the sum of those two angles in total must be equal to 180 degrees. So 90 degrees plus angle, this is the missing angle DCJ, in total it must be equal to 180 degrees according to rule 17. We subtract the 90 degrees from this equation and find out that the missing angle DCJ, this is the missing angle DCJ, this is equal to 180 degrees minus 90 degrees is 90 degrees. So this angle is also a right angle. So we found out that in quadrilateral DCJN we have four right angles. And we know that any quadrilateral that has four right angles must be at least a rectangle if not a square. Therefore, we relate to quadrilateral DCGN. This quadrilateral is a rectangle because it has four right angles. But you also know that the opposite sides of a rectangle are equal to each other. So in rectangle DCJN, side DC equals to side JN. But DC equals to 32, therefore the opposite side NJ must be also equal to 32 units in its length. And we also know that side DN is equal to side CJ. So if we focus on those two right angles, in those two right angles they have the hypotenuse DA equals to 41 and the hypotenuse CB also equals to 41 according to what is given as the question. So the hypotenuse of those two right angles are equal to each other, and side DN also equal to side CJ. if you have two right angles with one side and the hypotenuse one side and the hypotenuse of one triangle are corresponding equal to the hypotenuse and one side of the other triangle, then the two right angles can go into each other according to side rule. Therefore, those two right angles can go into each other according to side rule. And therefore, side AN equals to side JB. According to the rule that corresponding sides in congruent angles are equal to each other. Those two right angles can go into each other, and therefore the two corresponding sides, that is to say AN plus JB, must be also equal to each other. So, if we define side AN as x, then side JB must be also equal to x because they are equal to each other. So, we know that AB in total equals to 50 units according to what is given in the question, but AB equals to AN, that is x, plus NJ, that is 32, plus JB, that is also x. So, x plus 32 plus x in total, it must be equal to 50. Read again. AB is equal to 50, in total it is equal to x plus 32 plus x. X plus x is 2x, so 2x plus 32 equals to 50. If we subtract 32 from this equation, we find out that 2x equals to 50 minus 32 is 18. So 2x equals to 18. Here we divide this equation by 2 and found out that x equals to 9 units in its length. This is the missing side. X is equals to 9 units in its length. This is the missing side JB equals to x. This is also equals to 9 units in its length. In the next step, I copied the right triangle CJB in a new page, this right triangle CJB, and we implemented the Pythagoras theorem on this right triangle CJB. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this is the right triangle CJB that I copied from the original domain. According to the Pythagoras theorem, CB squared, that is the square of the hypotenuse, equals to CJ squared plus JB squared. CB is 41, therefore CB squared is 41 squared, that is 1681, and this is equal to CJ squared. CJ is the missing sign, so it is plus JB squared. JB is 9, therefore JB squared is 9 squared, that is 81. So in total, we actually found out that 1681 equals to CJ squared plus 81. Here, subtracting 81 from this equation, we found out that CJ squared equals to 1681 minus 81 is 1600. So 1600 equals to CJ squared. Here we took out all those equations, we found out the missing side CJ equals to the square root of 1600, that is 40. So this is the missing side CJ, that is equals to 40 units in its length. CJ is the height of trapezoid ABCD. Again, CJ is the height of trapezoid ABCD. Why? Because it creates 90 degrees with the base DC and creates 90 degrees with the base AB. Therefore, CJ is the height. And we know that the real trapezoid ABCD equals to the sum of its two parallel bases times the height over 2. And again, the real trapezoid ABCD equals to the sum of its two parallel bases times the height over 2. Side DC and side AB are parallel to each other, therefore the sum of its two parallel bases are DC plus AB times the height CJ over 2. Because again, the height of the ABCD equals to the sum of its two parallel bases, that is AC plus AB times the height CJ over 2. DC is 32 plus AB is 50. We just right now found out the CJ, the height CJ is 40 divided by 2. So total, thereafter, trapezoid ABCD equals to the sum of its two parallel bases, the sum of the two parallel bases of trapezoid ABCD, DC is 32 and AB is 50 times the height CJ, that is 40 over 2. 32 plus 50 is 82. And we have 40 over 2 is 20. So total the area of this trapezoid ABCD equals to 82 times 20. 82 times 20 is 1640. So if you found out the area that we are looking for with this question, that is the area of this trapezoid ABCD is equal to 1640 square units in its size. Okay, thank you very much.